Hello, class. The concept that we're going to go over today is called arc length. And we already have been discussing circumference, and circumference is the outside of the circle. It's like the perimeter of a circle. What we already studied is angle measures, and we studied, for example, if I look at this picture, that if I have angle APB, if I know what that angle is, then I'll know exactly what that arc is. That's arc measure. But today we're going to be able to figure out what would just this arc length be. So what you already were just doing is figuring out the circumference of the entire circle. But now we're just going to be able to find a piece of the circle. So what is arc length? It is a portion of the circumference of the circle. It's not the whole circle, it's just a piece. And it would be, let's say we went to a park and instead of walking around the entire park, we just wanted to walk around a quarter of it. Or maybe we wanted to walk around half of it. And then we want to find out what that actual length is. So in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. So it's a little wordy. What does it mean? It simply means that the arc length of AB over 2 pi r equals the measure, which is degrees, over 360. That's one way to write the equation. We could write it as a proportion and we could cross multiply. Or simply, we can just take the percentage, whatever the degrees is, of this central angle, divide it by 360, and multiply it by the circumference of the circle. Now, they have 2 pi r here as the circumference of the circle. We can use 2 pi r, or we can use diameter times pi, because remember, 2r is the diameter. So let's look at our first example and go through it together. I asked you to find the length of an arc measuring 90 degrees on a circle with a radius of 4 centimeters. So this is what I'm trying to describe. Instead of going to the park and walking around the entire park, which is the circumference, we just want to figure out if we started here and walked here. Well, what we need to know is what percentage of the circle is this? Well, it's 90 degrees out of 360, which if you simplify 90 divided by 360, it's a quarter. So all this arc is a quarter of the entire arc, the entire circumference. So what would be the entire circumference? It would be 3.14 times the diameter, which the diameter is 8, or 2 times the radius. What do I need to do? I need to take that 25.15 and multiply it by 90 over 360, which is a fourth. So you can multiply by 4, you can multiply by 0.25. It doesn't matter. You can put 90 over 360 in the calculator. Once I multiply 25.15 times 0.25, my answer is 6.28, or 6.3 is probably what I'll have us round to the tenths. So with that same concept in mind, I'd like you to try the problem on your own. You have an arc. Instead of just being a quarter of the circle, we want to go 256 degrees out of 360 instead of the whole circle. So go ahead and try that problem. So in order to find the circumference of the entire circle, we would take the radius 10, multiply it by 2, 20, and take 20 times 3.14. That answer, 62.8, we would multiply times 256 over 360, which as a decimal is 0.71111. What I'd really prefer you to do is put the entire equation in together. Put 3.14 times 20 times parenthesis 256 divided by 360. This way you don't have to round and then you're not getting exact. So 4.66 or 4.44.7. That's the arc length. That's what we're finding. We're finding the length, which is in feet, inches. That actually should be feet because one tick mark is feet. So please just make sure you're realizing that you're finding length, which is circumference. So please try, these are two problems. I'd like you to just do these on your own. There's really no difference. They both have 60 degrees as the central angle or the measure. You're finding the length of AB here. You're finding the length of EF here, and the only difference is the radius. And so you should have taken 16 times 3.14 times 60 out of 360, or if you realize that is 1/6, so you could have put 1/6 instead of 60 out of 360. Final answer 8.37, or since I said now we're going to round to the tenths, 8.4. EF, exact same thing except 22 times 3.14 and then times the sixth. So there's no other concept here. It's exactly the same concept. I just can ask for different things. If I have a formula and I know it's arc length, for example, if I go back, it's arc length equals measure over 360 times 2 pi r. Well, I can look for the length, I can look for the measure, or I can look for the radius, or I can look for a diameter, or I could look for circumference. So all this is just coming back to algebra. So when I look at this circle, I tell you that the arc length of AB is 6.77. The radius of the circle is 4. Well, what I'm looking for is the measure of angle APB. So I'm just going to set up an equation that is arc length equals the measure over 360 times 3.14 times the radius times 2, or I just put 8 there. So go ahead and put that down. See if you can solve that without me. If not, I show you my steps. First thing I do is multiply the 3.14 times 8. I made it 25.12. If you are rounding numbers in a problem, you want to keep it as far out as you can. You don't want to make that 25.1. Well, I wouldn't do anything here because this is in parentheses, so I'd get rid of the 25. I get rid of the 25 by dividing. So I do get a decimal. I take 6.77 divided by 25. I get 2.2695. Again, keep this at least 4 numbers. And now I have a fraction and 360s on the bottom. So to get rid of it, I multiply by 360. And the central angle in this problem would be 97 degrees. My next problem. I want to find the length of PS. Well, finding the length is something we've been doing over and over again. That's what you just did for the last 4 problems besides the one you just did. So I know that arc length equals measure times 3.14 times the diameter. And you have to see QS is the diameter, and I tell you that that's 9. So that is the diameter, so I don't have to multiply it by 2. And the only thing is, you might say, well, why am I using 105 instead of 75? Well, remember, I'm trying to find PS, which is this arc. This arc goes to this angle. Well, how do I get the angle? I know QS is a diameter. So under here is how much? 180. So I take 180 and I subtract 75. That's how I got 105. So you just have to make sure that you are using the correct angle with the correct arc. So the length of the arc, I'm simply multiply. You don't need to do this in 2 separate steps. You could simply just put it in a calculator. Make sure you're putting parentheses around this. Getting my final answer to be 8.24 or 8.2, since I said we're going to do the tenths. I have 2 more problems, and they're similar problems. I give you an arc length this time. I give you the measure, but I'm looking for something else. In this problem, I'm actually asking you for the circumference. Now, some people might not be able to see that right away. So I set it up like this. I set up the arc length, 61.26, equals the measure over 360. So 270 is the measure that goes with this arc length over 360. I multiplied it by pi, and then I times it by the diameter, which is what we've been doing. When I do this math, I simply made that a decimal. and then I multiplied those together. So 0.75 times 3.14 is 2.355. You could do that all in a calculator. And I divide, oops, sorry, that should be D. And then I get the diameter is 26. So once I get the diameter, which is 26, that's great. Diameter, perfect. From diameter, I could find radius, but this problem wants circumference. So from the diameter, I just take diameter times pi, and that's my circumference, so 81.68. Now, if you can pick up on the concept that the formula is arc length times measure over 360 times 3.14 times the diameter, 3.14 times the diameter is circumference. So I could have just put an x there. Then I could have just made that 0.75x, and then I could have divided an 81.68. I am absolutely fine with either way. Just some people, if you're sticking to your original formula and not wanting to change anything, that's absolutely fine. Just please realize you will find the diameter, and from diameter, we will find the circumference. Next problem is extremely similar. Let's analyze what I give you in the problem. What I need you to realize by the time I come back on Tuesday is that EF here is 10.5. That's arc length. That arc goes to the measure 150. So if I was setting up a problem, now what do I want? I want my radius. So you can either use D in your formula or you could use R. Since I know the relationship, I'm just going to use R, but you have to remember that if you change the formula from diameter, that you add a 2 in there. So I set arc length equal to measure over 360 times 3.14 for pi times 2 times R. Now, if you just put D here, that's fine. Solve for D, but then take your answer and divide it by 2. So I change this. I keep 4 digits if you're doing this. What you really could do is just take 150 divided by 360 times 3.14 times 2, all in a calculator. So that number comes out to 2.617 R. Divide, and my final answer is that R is 4. Sorry. So I'm hoping that you're picking up a concept that this is a formula. The arc length equals measure over 360 times circumference. All you're doing is finding a portion of the circumference. So if I have a formula, and as long as I have everything but 1, I can use that formula to solve for the missing piece. So these first 3 problems were just finding the basic arc length. 5, we found the measure. 6, I went back to arc length. 7, I asked you to find the circumference. And in 8, I asked you to find the radius. So it's all the same concept, just using the formula to find different pieces. Don't worry, we'll practice this concept when I get back. All right, I hope you have a good day.